Hi, welcome to class. My name is Don LaFon, and this week in our A+ software class, we're beginning to cover a very important chapter, Chapter 13, Networking. Now, in this chapter, we're going to divide it into three different pieces. We're going to introduce hardware, the cabling, for example, in the first presentation. The second presentation, we're going to talk about OSI model, third presentation, and a little bit of subnetting, and then we'll finish in the third presentation with more information about networking, including a final presentation about variable length subnetting to make sure you guys know exactly what you're doing with that field or in that concept. I'm going to go ahead and share my screen and start the presentation. And then I need to check this side, almost there. He's going to move this. All right, we are ready to go. Let's learn about networking. Now, in our today's presentation, we're going to start with soft skill. Soft skill we're going to talk about is being proactive. Then we'll also talk about network. I'll give a network overview, networking overview, network media. That's the actual types of cables. Then we'll talk about a network overview again for next week, and we'll finish in our third week with cloud technology. So these are really high level. We get a lot deeper into each one of these, but let's go ahead and get started. Again, this is our textbook, pages 619 through 642, Chapter 13, Networking, Part 1. Let's start with the soft skill, and that soft skill is being proactive. To be proactive, you guys know what being proactive is. To avoid being caught offhand, right? Ultimately, you want to think of ways to improve a situation. You want to anticipate problems, and you want to fix problems before you're being told to do so. After you fix a problem, you want to make sure you follow up with a service call to make sure that you did fix the problem and that the problem that you solved was a permanent fix. Every now and then, even myself on my own computer, I'll fix a problem until I reboot it. When I reboot it, all of a sudden the problem comes back again. Had that problem today, as a matter of fact. And so you want to, it's not a bad idea. Well, there's one company that I talk about. They don't pay me to do this, but ASUS, I've had fantastic technical support with ASUS. And I had a problem with a brand new router. I was installing a mesh network, and I couldn't get it to work. I called them. They were fantastic. They got right on it. They solved the problem. And then surprisingly, a week later, they called me back to see if what they had done on the first call actually solved the problem. Now, granted, it was cutting edge technology. That I had brand new router, it was brand new software, brand new drivers, I'm sure. And they were just checking to see if the solution they gave me would be worthy of giving to future customers that called in about the problem. But I loved the fact that they followed up a week afterwards to find out and to check with me if the problem was solved. So thumbs up to ASUS, and I'll probably always buy ASUS equipment if I have an option. You don't have to. There's a lot of other good companies out there, but they've won me over with their customer support. You can give me comments down below if you've had different experiences or if you have a similar experience with ASUS. By the way, if you're watching this video on YouTube, please make comments down below in the comment section. I'd love to follow up with people out there on the internet that I'm helping or I've been able to help. I love hearing from you. And if you're watching this video in our classroom, Netiquette classroom, ask questions in our help discussion forums. And if you are watching this with me live, just hold your questions until the end of the presentation. Although I will go ahead and open the chat room just in case I ask you a question or if there's anything you want to add to the conversation, you're welcome to do so. All right. Skip that at the beginning of today's video, but it's okay. So what else? So provide a list of recommended solutions or procedural changes to the supervisor, rather than waiting for the supervisor to delineate those changes to you. It's always, and remember, just like when you make recommendations to your parents, they don't always follow those recommendations. If you make a recommendation, you're being proactive. They don't have to follow, especially if it costs the company money. But you made the recommendation. Later, when they have multiple complaints or multiple other problems that occur that are similar to what you're seeing, they may fall back to your solution to solve that problem. So always pass up your solutions. When I worked at America Online, it took 30,000 phone calls, tech support phone calls. And whenever we would find a solution, or at least we thought we found a solution, we would absolutely pass it up, because then it would be spread among the thousands of technicians that were answering phone calls. And then those recommendations would then be either thumbs up, it worked, or thumbs down, it didn't work for me. And we were able to find solutions that worked for a majority of the customers. So I've actually seen this work in person. Have a list of standard software loaded on a computer, such as the operating system on the computer, such as an operating system, service pack, and any applications that are standard throughout the institution. You can have those either on your laptop, or I recommend having it on a USB drive. Back in the day, we used to put it on a DVD, but nowadays we don't find DVDs in every computer. So you'd be better off having a USB drive loaded with all the software that you need to make a new installation, or maybe a new ghost image on the computer, and then troubleshooting software as well, not only, and drivers as well. And then being proactive saves the technician and the customer time and ultimately money. So think about if you were to get to the customer, realize you need a certain software that you left back at the office, you need the installation software, you can't get to it online, because maybe their internet is down. That's possible, right? You think you're going to get to a client and then just jump online. You have all your tools up in the cloud. You're just going to download what you need, but you can't get to the cloud. Now you've got a problem. So there is a reason to have everything on a USB drive attached to your keychain, instead of out in the cloud. Good idea to have a storage location out on the cloud with those files, secure location online, but it's a better or just as good idea to carry them with you on your USB drive. All right, keep going. Being productive can't hurt. Networking overview. So network example. So we don't just have a network with routers and switches that connect computers, ultimately making the internet. You are used to having a network. We do it. We have a telephone network where you are able to pick up a phone and call anybody in the world thankfully because of networks. Think back in the day with networks, you've seen videos and pictures. Hopefully, most of you are not old enough to remember when you pick up a phone, you didn't dial a number and call somebody, you talk to an operator, right? I think it was 411 the other day instead of 911, and it was I was surprised when it said that it was disconnected. It says we no longer support 411. Back when I was young, you dial 411 to find phone numbers. Now we just Google the phone number to find it. Anyways, so telephone network's a great example. Roads, interstate highways, excellent example. Electrical network that provides electricity to our homes and businesses. Cellular network that allows you to communicate with other people anywhere in the world. Air traffic control. Your network of friends and family. How about the post office? That's not listed there. The post office is what I use when I'm talking about networking to describe how to address an envelope and with source and destination addresses, your home address and who you're sending it to is similar to an IP address being sent to somebody at a remote in a remote network from your network. We'll get to that when we start talking deeper into networks. But all of these are examples of networks you're familiar with. Um, there are types of networks in computing as well. We have computers that can connect to different types of networks, including a, a, a personal area network, a small wireless network such as Bluetooth, keyboard and mouse connected to a PC. My phone has Bluetooth. I love my phone's Bluetooth. I talk on my phone. My dog is messing with my camera. I keep having to fix my camera because he keeps moving. He's under my desk. It's the way it is. Anyways, I love how my phone, I can be listening to wireless speakers in my office or out on the deck, and then I can stop the signal and I can turn it back on again when I get in my computer. In my car, and my car automatically determines what I was listening to and picks the song right up from where it was. So that's a personal area, within 20 feet, roughly. There are newer versions of Bluetooth that are a little bit longer than that, but most Bluetooth will not range from one side of your home to the other side of your home. One side of your office to the other side of your office. Normally, it's within a personal area where you currently are. LAN, local area, shared resources to a single area, such as a room, like a classroom, a home, or a building. At your home, you probably have a wireless router. That wireless router allows you to connect your phone or your laptop computer, any other wireless devices you have, such as IoT light bulbs, my dryer, my coffee pot, my range, all connect to my LAN, all communicate with it. When my dryer stops, I get a notification on my phone. It's pretty cool. A MAN, metropolitan area network, spans a city, such as a municipal community college campus. Bigger than that, Seattle is the one experience that I've had. When you visit Seattle, a state and city in Seattle, Washington, and Washington State, USA. When you visit that city, the entire city is wired as a MAN. No matter where you are, you can use the internet. Now, it's not free. Ultimately, the people that live there pay for it in their taxes, but it allows for you to go from location to location without dropping signal, whether you're in a coffee shop or restaurant, sitting in your car, at a park, you're using the same wireless network, same access to the internet. It's fantastic. Other places like, say, a large city like Jacksonville, Florida, for example, it's got a 40 mile by 40 mile range just for the city. So that's 1,600 square miles. I think I did my math right. 1,600 square miles. A MAN wouldn't make sense in a city as big land-wise as Jacksonville. But downtown New York would be New York City, or any city in Europe. Paris, for example, would be a great place to incorporate a MAN. Wide area network that spans large geographical areas. So you connect on a WAN from city to city, country to country. You can think of all of the undersea cables that connect the continents as an obvious example of WAN connections. But you also could have company to company. My college that I teach at has 7 different campuses. They're all considered connected by a WAN. Now, sometimes people even use the term WAN to talk about connecting building to building with LAN inside of a building, but then a WAN connection from a building to another building. So on a college campus, there could be multiple buildings all connected by WAN connection, point-to-point connections. That would also be considered a WAN. So don't always think big as the world, big as the country, big as it could be as big as a campus, depending on how your network is actually laid out. There's also wireless LAN. Those are wireless access points that allow you to connect devices wirelessly to a LAN type environment. So on your campus, you bring your laptop, your college campus, you bring a laptop, you're able to connect to the network, even though you're not physically connected with a, a device. There are also wireless WANs. That's a mix of technologies such as cellular or WiMAX. Now, interesting thing about WiMAX, we don't use much of it in the United States, but WiMAX does allow for a large geographical area. WiMAX is point to point, but it's a visual, so it doesn't work here in Florida. You would think it would, but we're flat, and so it's really hard for areas of the city to communicate. So it was tried here. It doesn't work here, but other places in the world, WiMAX does work, and it's wireless WAN. And then there's a wireless mesh network that's great for emergency situations for connectivity among rescue workers or in smart devices. There is a wireless mesh network in let me get the name. Hang on a second. So I opened a website while I was put you all on pause to give you an example of a wireless mesh network. Helium, the Helium network is a type of crypto technology that allows people to have wireless connections, and it's lo-fi. They provide a low fidelity, short range wireless connectivity for free and the example and you don't own it, but it's divided into octagons, I think, if I remember right. And what basically, if you were to lose your pet and you have a pet transmitter that's lo-fi that can communicate via this network, you would be able to, if your dog got lost, you would be able to find your dog because other people would have nodes, they call them nodes, that are enabled, and you are able to communicate to find a package that's missing or a dog that's missing or rescue workers. It's a good example. Take a look at the Helium network. It's spelled Helium. I believe, is there two L's in that? Nope, just one. Helium, the Helium network. And it's very interesting. And I've actually ordered some Helium hotspots for my home. They just haven't come in yet. Otherwise, I could possibly show you what I'm talking about. But that's a good example of a wireless mesh network, a WMN. Okay, continue on. Attaching different types of networks. So computers can attach to different types of networks. A server-based network, computers users participate in a domain and log into the main computer called a server, where they are authenticated, authorized to use the network using an AAA server, authentication server. Now that would be a good example of when you go into your work or school and you have to sign in using a username and password. You are being authenticated by a server somewhere in the network that says, yes, you have authorization to use those computers. It could be a password. It could be a device that you have. It could be a card that you swipe. It could be a code on your phone that you have to enter. Lots of different ways to authenticate a user in a network. But there's a server of someplace that is serving the purpose of authentication. Could be a work group, Windows computer in a peer-to-peer network, or known as a work group. If you have multiple PCs set up at your home, you can set up a Microsoft home group. Microsoft calls a work group a home group in Windows 7, 8, and 10, and then it's removed in version 1803 and higher. So you can still network, but you can't use it using the home group in the newer versions of Windows 10. Home group networking is assigned you're assigned a single password, and other devices within that home group simply need that password to access resources such as files and folders. I've had one set up in my home multiple times over the years with different versions of Windows 7, 8, 10, and I haven't set it up with 11. I'm not sure if it's available with 11. I should check right now. Hang on a second. Let me see if it's possible. One moment. Well, I'm glad I took a look because Windows 11 does not have home groups. And when I started searching for a replacement, I was unable to find anything that was really fast and easy. So it doesn't look like Windows 11, it doesn't look like they replaced it with anything. It looks like they just removed that capability. And that would explain why none of my Windows 11 have a home group set up. It's because it doesn't exist on Windows 11, and all my computers are Windows 11. So, all right, let's keep going with home group. But you do have to be aware of it because the certification exam has home group in it when it relates to Windows 7, 8, and 10. Okay. So there are different topologies for physical networking. There is the star network, where you have a single device in the middle of multiple hosts, for example. This is what we have in the most simple form when you have a classroom and you have 24 computers. Those 24 computers are all connected to probably a single switch. Now that single switch is then networked to another switch that connects multiple switches. So all of the different classrooms in your building all go to a single switch, and the single switch connects to a router. Here we have an extended star topology where all of the switches are all connected together to access all of the devices. Now that's less likely because of the broadcast domain. It can be the case, but usually you would have a router dividing networks. So we'll come back to that later, I'm sure. Ultimately you want networks for host devices, and then you want those networks to be separated. So some form of these three is what we have inside of in today's technology. With routers, this would be a router, or maybe there would be a router right in the middle here that would have all of these switches all communicating with it, with all of these being in different networks. Now, ring topology and bus topology, those are legacy physical network topologies that really aren't used anymore. Now, you have to be aware of them because when you get out to the field, you might find an existing ring topology or a bus topology that's in place that they don't want to bother to replace. The problem, well, let me tell you how a ring topology works. There's a token. The token is passed along the network, and when a device has the token, that's when it can communicate with the network. It's its time slot, and then it just, let's say this host puts a package destined for this host. It would send it along. This one would ignore it. That one would ignore it. That one would ignore it. Then this one would get the packet, and then it would respond. Let's say there's no response, though, then it would pass the token on, and this one would then have control of the network to do whatever it's going to do. So the problem with the ring topology is whenever there's a break in the line, the entire network goes down. So even if you're just adding another node to this type of topology, and you bring down the network to add that additional node right here, for example, then the entire network is brought offline, and there's no communication because that token cannot make the circle when the circle is broken. It's also very difficult to troubleshoot a ring topology because the whole network is down. It's hard to figure out where the problem actually exists. Same thing with the bus topology. Bus topology is similar. All devices are connected to a single line that has terminators on each end. Now, if any point along the line is broken, you would think that each side would be able to communicate, so you would be able to troubleshoot. But that's not true. The entire network is offline. The terminators are required to be able to complete a network. If you will, to pass a signal back, you need a terminator. So this topology no longer is used either. But if you have it again already installed in a network in a building, they're not going to rerun wires. Whew, easy for you to say. They're not going to rerun wires just to make it something else that works better unless they have to. So they'll wait till they have to upgrade to better physical cable, like a running new Ethernet cable. When they have to upgrade, that's when they'll make the change and then change it over to a star topology. Now, mesh topology, we still use a mesh topology in small networks that we have. That's where you have multiple devices connected to each other. It's great for redundancy in a small network. You can have 2 switches, 3 switches, PCs connected to 2 switches. If one goes down, it's still connected to another. Works great. Wireless mesh is all the rave in 2022. Everybody wants a wireless mesh. I have a wireless mesh in my home. One router goes down. I got 2 routers that pick it up. I got 3 routers in my home that all talk on the same network, which does make it difficult to troubleshoot sometimes, because when a device isn't communicating anymore, is it one of the routers that's sending out bad information and not communicating? What's the problem? I end up having to bring down all of the devices and bring them all back up again to troubleshoot. It is difficult to run a mesh topology with multiple devices. Let's picture they only have 5 devices here. What if you wanted a mesh topology up here with 8 devices? Every one of these devices would have to be connected to every other one of these devices. You can see that would be a nightmare, not only in the cost, but also in the running the wires, right? You would have to literally, every device would have to have 8 connectors to be able to connect the other 7 devices to it. So mesh, really talking about just wireless and very small networks. Network media. Copper, it is the most common cabling. Copper medium is the most common cabling. It's used to connect devices to the network. It's also used to connect network devices. Copper media uses 2 major types. By the way, when we're talking about twisted pair and coax, when we're talking about copper, we're talking about Ethernet. That's the technology. When we're talking about Ethernet cable, you might hear it used as Ethernet cable instead of just copper cable. And then with Ethernet cable, you have twisted pairs. They're named because there are 4 pairs of connectors, similar to phone cable. Those were twisted as well, but you didn't have 8 connectors in a phone cable. The RJ45 Ethernet connector won't fit in the old phone cable. If you have an old phone, Ethernet cable is too big to fit in that phone connector. It's smaller. Twisted pair cable comes in 2 types, shielded and unshielded. What you're looking at right now is unshielded. There's no shield on any of the individual pairs or on the plastic cabling on the outside. So what you're looking at is unshielded twisted pair cable. Now you pay a little bit more money and you have shielded twisted pair cable. It has foil around that provides more shielding. It's used in industrial settings such as factory where extra shielding is needed to prevent outside interferences from interfering with the data on the cable. And that shielding, by the way, let me go back here. I want you, this is a really good picture. I want you to note that the twists in the cable are at different twists per foot. So this is much, you can easily see it here with between the orange and light orange and green and light green. These two, this is, I'm sorry, blue and light blue. This is much tighter than this one. The reason why they're twisted at different twists per foot is because it helps to reduce EMI, electromagnetic interference between the cables. The fact that the fact that it's twisted is to avoid EMI with other cables outside of this jacket here, another cable that's running right next to it, for example. That's why they twist it, and they twist it at different rates so that this cable doesn't interfere with this cable. Now, continuing with unshielded twisted pair, we have UTP is the most common because of the inexpensive lack of shielding causes the cable to be very inexpensive, especially compared to fiber, which is super expensive. It's measured in gauges. For the gauges, lower is thicker wire, and it is found in categories of 5E, 6, and 7. You can find it higher than that. The higher cat has better shielding. One of the shields, I don't have a copy of it right here, but one of the shield has shielding on the individual twisted pairs and on shielding on the plastic, underneath the plastic encasement. So it has multiple layers. I'm not sure if that's Cat 6 or Cat 7. I could look it up, but you can too. So take a look and let me know down below if you find a good a table that can show you all of the different cats and where what the differences are. Now, where they finish inside of a RJ45 connector. That connector has 8 slots that you slide the 8 individual pins, 8 individual wires in. Now, you would think that a straight through would have the wires would be literally straight through, but they're not. They're divided into either T568B or T568A. Now, if you look here, if you look closely, T568 goes light orange, orange, light green, dark, straight, solid blue, light, I call it light blue, but it's really white and blue mixed, but I call it light blue, green, light brown. But you see it's switched. And the reason why they switch is because if you're connecting like cables, like devices, like PCs to PCs, you got a gigabit port on the back of your PC. You can connect it to another PC, just like you could connect it to a router. But if there's no software in the device to automatically convert it, then the devices talk on let's say the light orange, right? And they listen on the solid orange. So they can't communicate because they're both talking on the same wire. They're both listening on the other wire. You need to switch it so that it's talking and listening, talking and listening. I hope that makes sense. But anyways, that's how I explain it in a classroom. And if you have any questions or a better way of explaining it, by all means, if you're on YouTube, you can post a video link or something down below in the help forum. I'm sorry, in the comments, and you can help your fellow students. Anyways, that's like devices. They either have T568B on both ends, or I'm sorry, that's straight through cable. It has T568B on both sides or T568A on both sides. Now, a crossover cable actually takes a 568A on one side and a 568B on the other. And you need those, with those devices, that's how you can connect like devices like two PCs to each other. You have to have a crossover cable. Now, in Cisco equipment, there's software that runs all the time, running in the background, that if you, unless it's disabled, if you connect two cables together, it will automatically determine what kind of cable it is and configure whether it needs a straight through or crossover cable. And that Cisco software is called Auto MDIX, Auto dash M as in Mary, D as in Don, X. Now I'm not going to show you a video on how that works, or the cabling on that, because it's beyond the scope of this class. But just know that if you have like devices, like two PCs or a PC directly connected to a router, you would need to have a crossover cable, because otherwise they can't communicate. You would need to have a crossover cable to be able to connect two like devices. And back to the Cisco again, they have something called Auto MDIX, and Auto MDIX allows so you don't have to worry about what the cable is. Okay. And when we're working with devices inside of a corporate environment, you probably don't have patch cables in your home, although some people do. I know nerds. I myself personally, in one of my homes that I've owned over the last 30 years, I actually ran cable to patch outlets in every room in my house when they were building the house. I took the time to run all those cables. But I never had a switch on the other end. I never could quite get it to work. I wasn't a networking teacher back in the day, and I didn't understand what I was missing, but I couldn't get it to work. All I was missing was where all those cables came out in my office. I just needed to connect all those cables to a switch, and then that switch could be connected to a router directly, and then the router would manage the switch, an unmanaged switch. In Cisco routing and switching, you learn how to manage the switch, putting passwords on it, enabling different technologies to cut down on broadcast storms and things like that, STP, for example. But that's beyond the scope of this course. What you need to know is what we do is you take cable that doesn't have connectors on it, and you run it from the different locations where your PCs are going to be, through the walls into the attic, ceiling, whatever, and then you run it to the network room, where it there goes to a patch panel, and then the patch panel has all of the. Let me see if I can figure out how to zoom in on this. I can't. End devices. I'm forgetting the name of that right now. I'll come up with it in a minute. Somebody can help me in the chat room. But anyways, so you run the cable, you connect it to the back, and then in the front it's just a port, and then the port you run your RJ45 cable to. So those long wires that are run from room to room, you have these different end here. Did anybody put that in there? Nope. Hang on a second. Okay, so I didn't get the term I was looking for. Everybody just calls it a patch panel. Anyways, so I have a video here to show you what I'm talking about, so it makes more sense.
What is a patch panel? A patch panel is a panel with an array of Ethernet ports on the front and places to punch down bare wires on the back. Each port on the patch panel, labeled with a number, will connect via an Ethernet cable punched down on the back, through the wall, crawl space, or attic to another location in the house. This other location will have the same Ethernet cable terminated at a wall plate. Needless to say then, a patch panel is something you would only consider if you are going to use wired Ethernet connections in your house or office. If you only do Wi-Fi in your house or office, then there is no need for a patch panel or switch or any of the other nerdy things featured in my videos.
All right, that's enough of that video. Pretty simple concept, and you can explore more if you'd like. That video um, was provided by, who is that video by? Let me see so I can give credit. That video is provided by, um, ah, it's not there. I don't have it. Budget Nerd. Budget Nerd gave us that video. So you can go take a look at Budget Nerd patch panels. Do you need one? Anyways, to see how a patch panel is run, and they just call them um, knock. I think it was a knock. He called it a knockdown, but it's not a knockdown. It's a damn, I can't. Hopefully, I come up with that term. I apologize. You can put it down below in the comment section or send me a message inside of our classroom. Show me that you're paying attention and you know what I'm talking about. But anyways, it's on the back of this modular wall jack. You connect it to a just put the wires in a little slot and you push it in. I forget what it's called. I'm sorry. I should know, and you should know too. I don't want to hold up this presentation though. Anyways, so let's keep going. So protecting your networking cable investment. I have seen some cable panels that look like this. I have seen them. Some in this. This isn't too bad. You can see the wire runs and nicely done. Your equipment should be nicely wired, not just one big mess. You should also have your equipment in a secured room. And the reason for that, these cabinets can be locked, but the room itself should be locked as well. These cabinets should have AC supply and exhaust. The room itself should be have AC supply and exhaust. And you should have locking, it all should be locked down because as I will show you when we talk a little bit about packet tracer at the end of this presentation, if you were to take a laptop and with a Cisco console cable called a rollover cable, a console cable, you can connect your laptop to the back of a router or a switch. If it doesn't have passwords connected, you're into the network and you can do all sorts of damage, or bad guys can do all sorts of damage. So you definitely want to make sure locking your equipment is just one more way of protecting your network. Make sure you have professional cable management, so when you have a problem, it's easy to identify and to fix. And make sure you don't put the wires where you can trip over them. Even when you're in a classroom, that's an issue sometimes. If they get sloppy with the wires, I've had students actually kick a wire and disconnect it from the back, and we troubleshot for hours, not realizing that it was simply the cable that had pulled out of the back of the computer. Networking troubleshooting tools. Now, I like to talk about these two devices here. You've seen wire plugs, and this is just testing for a signal. But these two devices here, you connect one side to one side of your cable run, and the other side, this is the sender and this is the receiver. The receiver can read the sender and know if it's got a good signal. If you've ever wondered how you can run 28 cables from the network cabinet to a classroom and connect 28 computers without putting the ends on them and without doing them one at a time, this is how you do it. You take these two devices, it's actually one device, so it will connect to each other if normal. Generally, they do. Anyways, then you have a sender and a receiver, and then you just test each one of the wires until you find it, and then you label it and you connect it to the right port, and then you go to the next cable, and on and on and on until you've identified all of your cables. Ethernet is the most common type of LAN. You could have some issues with Ethernet. For example, one side could be full duplex and the other half duplex. If that happens, you have a slowdown. Now, let me explain half duplex. Half duplex is like walkie-talkie. In walkie-talkie, only one side can talk at a time. So if you push down the send button and you say hello here, the other side can hear you. Let go of the button, the other person pushes down and says, hey, I'm here, I can hear you, over. And that's how the communication goes back and forth. But in half duplex, if both try to talk at the same time, in a walkie-talkie, if neither push down the button or if both push down the button, you don't have a communication. That's what's true with Ethernet concepts. There is still legacy equipment that uses half duplex, say maybe some old printers, for example, that still use half duplex. And you need to be aware that your communication has to be half duplex to those legacy devices. Most devices today, anything connected to a gigabit Ethernet port has to be full duplex. Full duplex, gigabit Ethernet is only full duplex. And that'll help avoid. Also, there's something called auto negotiation, where both sides will auto negotiate the fastest speed, and sometimes that auto negotiate will actually fail you. And if it fails you, then you'll have poor or no communication. One side will auto negotiate to a half duplex, and the other one will auto negotiate to a full duplex. If that happens, then you have poor or degraded or no communication. So they actually, in Cisco networking, they actually recommend configuring the configuring your ports as either full or half duplex and disabling the auto negotiation so that that problem doesn't happen. Ethernet over power. Think about all of the APs that you see in the overhead, the access points for wireless that you see in the overhead of businesses that you visit or your school. Each classroom has its own AP, for example. There aren't power outlets in the ceilings. What happens instead is your switch is power enabled, and the switch provides power over that same Ethernet cable to the power over Ethernet enabled access point, AP, and that's how the AP gets its power. You have to have special configurations for the you have to buy the right AP that's powered by power over Ethernet, and you have to have the right switch that can use power over Ethernet to send the power, and then the configuration is involved, and then you have that network set up and it runs fine. There's no plugs up in the overhead. And that is the end of this presentation. We'll return next week and we will cover networking part 2. Let me go ahead and stop sharing my screen. That presentation is just an introduction. I'll tell you, it's really hard for me, being a network teacher, to limit the amount of information I give you. I want to give you enough information to help you when you get on to my Cisco class next semester. But some of you aren't coming to my Cisco class. Some of you are programmers, or you're going to go into some other field that isn't routers and switches. So I don't want to go too deep in it. You just need enough information to pass that A+ certification, and there really isn't that much information on networking on the exam, but you have to be familiar with a lot of little things, not in depth with any individual element. All right, so there's 2 more things I want to cover for you in this class. If you are taking if you're just here for the A+ certification and you're watching this video on YouTube, thank you for coming to class. You can actually go if you'd like. I'm going to talk a little bit about where to get Packet Tracer and a little bit about Packet Tracer. You're welcome to stay. It's only going to be a few minutes, but I have to cover these items for students that aren't actually in live with me now. I've told you several times that I teach networking, and in our networking class, you are going. I have to share this screen again. Hang on a second. I have to share my screen again. And here it is. This is the lab you're going to do, 7.1 Introduction to Packet Tracer. Now, I could go through a packet tracer. You are ultimately going to use NetLab to create a packet tracer using the icon on the desktop that says packet tracer. Now, I have mentioned that I teach networking. So inside of our NetAcad classroom, I'm going to show you a video about how packet tracer works. It's just going to take it's a couple minute video. So let's play this video.
Hello, everyone. Tracer walkthrough video. In this video, I need to show you the different features built inside of the program known as Cisco Packet Tracer. As we get started, we'll highlight some of the key components of using the Cisco Packet Tracer application. Let's begin by taking a look at the bottom toolbar, and I'm looking at the bottom left corner. Here we have a variety of different categories, and in each category, we're going to have options below. For example, the default category is network devices. That's selected by default. In the network device category, we'll find the subcategory of routers. With routers selected, we'll see a variety of different model routers available for us to put into our topology. If I click on the next item, it's switches inside of our network device category. And then my list will now contain network switches that I can deploy inside of my topology above. The next category is hubs, followed of course by wireless devices, including then the next category of security, and then finally is WAN emulation for a wide area networks. Outside of the network device category, we can find the next main category of end devices. If I click on end devices, our default subcategory is an end devices of different types of hosts and other equipment we can put on our network. There's another subcategory for end devices, which is home. And this brings in a lot of our smart network-enabled IoT devices. We can go further by looking at citywide devices, which are under the category of smart city within end devices. If we continue on, the next component will be industrial, and then even power grid, all bringing some great features into Cisco Packet Tracer and the type of devices we can deploy in a network. To go even further into the realm of Internet of Things known as IoT, we have another main category known as components. And in components, you'll find a variety of different boards. Also, we have another subcategory for actuators and even sensors. These can be deployed in a network just like what we're doing now. To interconnect your devices, we'll be utilizing the connections category. In the connections category, we have two subcategories. We have connections, which is our common type of cabling we'll be using. But also another subcategory is structured cabling. And here you will find items that are available in physical view of Cisco Packet Tracer. And these will include patch panel connectors and wall mount. The next category is miscellaneous. And here we will find some custom-made devices with components already installed. Lastly, the category of multi-user connection allows us to interconnect our Packet Tracer instance with others across a local area network or even a wide area network connection. Let's continue by creating a small network utilizing our Cisco Packet Tracer logical view. By default, we can see our Packet Tracer is open in the logical view mode. This is where we can build a logical topology. I'm going to select the main category in the bottom toolbar of network devices. The default selection again is routers, and I'll go ahead and take a look at the routers available. At this time, I may want something like a 4331 Cisco router. I can click on that, and then I can click in our logical topology. I can continue by deploying now a network switch. I will click on the subcategory for switches, and I'll click the first switch available. I will then click on my logical topology, and now it is ready. At this time, I'd like to add on 2 or 3 end devices. So I'll click on the category of end devices. The default subcategory of our end devices is already selected. And I will go ahead and take one PC and click it on, put it right in the logical topology, and one laptop. I will click on the logical topology. At this time, I'd like to interconnect these by utilizing our cable. That is under our connections category. I will click on connections. The default subcategory of connections is already selected, and I will choose the appropriate cabling to interconnect these devices with the router and switch. I will use my straight through cable, which is the third option available. I will select it, click on my PC, choose the corresponding port of fast Ethernet, and connect that to the switch. And choose any available interface for network connectivity. I will repeat this by connecting the cable on the laptop, fast Ethernet, to the switch on another available network interface. Lastly, I'll interconnect that switch to the router in our logical topology. I'll grab the appropriate cable, clicking on it, click on an available port on the switch, and then connect it to the router on an available network connection. You will see indicator lights being shown here due to port status and connectivity. At this time, we have a small logical topology built. We will take a look at the physical topology of how we will be able to build a network and interconnect them in a physical view. I will click on the physical tab, and you'll see a change. The change is our screen is a little bit taller. The bottom toolbar might be in the way. We will have our ability to scroll on the right side of our screen by the sliding tab. We can see that there's the PC that I have clicked and put in the logical topology, along with the cable coming off of it. Also, we can see the laptop has been positioned on top of the PC. I can click and drag it and put it on the table next to the PC. If I scroll up, you'll see those cables from the PC and the laptop connecting to the switch. I can click and drag the switch, and I can lower it on our network rack. That switch is connected to the router. I can click and lower the router on the network rack in order to organize these devices and cabling better. In the physical view, I have the ability to use my main toolbar, and I have settings for zooming. I will click the magnifier glass with a plus to zoom in. Now you have a better view of the physical router with the cable that connects to the physical switch. And then if I scroll down, the physical switch with the 2 connections to the devices down below. If we want to manage our cabling, we'll right-click on a network cable and we'll be presented with 3 options. We can delete the cable to remove it completely. We can color the cable a different color so we can identify the cable and thus identify any devices connected by that cable easier. Or we can select Manage Cable, which will take the cable and will put it away nicely, which provides us a nice and tidy workspace. In the real physical world, that will allow us to organize our cabling, secure them appropriately, and keep them from disconnecting or from being crimped. We cannot use Manage Cable at this time for any devices sitting on a table or on a shelf. We can only use this Manage Cable option when devices are on our network rack on the left side. At this time, I'll scroll to the top, and you can see that we have our switch and our router. I can right-click on the switch, and I can say Manage All Cables on Device. When I select that, you will see that the cabling between the switch and the router looks like it disappears. Instead of it just keeping our cables nice and tidy between the actual switch connection to the upstream router connection. If I right click on that switch again, you'll see we have the options to inspect front, inspect rear, to delete the device, or to unmanage all cables on the device as well. By unmanaging all cables on the device, we see the interconnected cable between the router and the switch reappear hanging down on the front of our network rack. If I right click on that switch and select Inspect Front, we'll get a closer view of our network switch. Again, we have our magnifier glass options to zoom in. I will click on Zoom In, and then I will scroll to the right and down my packet tracer window. We can see that I have port 10 on the switch connected to a device. If I hover over that connection, we'll see it's connected to device PC0. We'll also see there's a link light on for port 20. If I hover over that connection, we'll see that this connection goes down to the laptop. And lastly, if I hover over the gigabit connection on the far right side of the switch, we'll see that this connects to device router 0. This is great information for us to be able to document and visualize our interconnected physical network. But also, if I close this off, again, we can just follow those cables and see where they interconnect to the devices. If I right click on the switch, we can also select Inspect Rear. When we click Inspect Rear, we will get a rear view of the Cisco switch. Again, I'll use my magnifier glass, and we will be able to click and zoom in. Here we will see the console connection for us to complete our initial configuration of the switch. Also, you'll notice that there's no power button on the Cisco switch because the Cisco switch is automatically powered on once it's connected with a power cable. To remove power, we would unplug the Cisco switch from any power source. If I scroll back to the left side, we can do the same with router 0. We can right click and inspect front, and we can zoom in and get a better view of the Cisco router and any connections, as well as any available slots that we can install any new components or additional features on. I can right click on the router again and click on Inspect Rear. And again, I'll zoom in. And here on the router, we can see that we have an aux port, we have our console port, as well as we have a management interface. On the right side, we'll see that we have a power button and the current status of the router is powered on. If I click the power button, the green light will turn off and the power is now disabled for the router. I click it on again, and now the router is actually booting up since it has received power. I will click the X to close the rear view of the Cisco router. If you want to deploy new devices onto this current physical topology, we will use our bottom toolbar. I will select End Devices, and in the End Device subcategory, I would like to deploy a server. I can click on the server, and I will click on the network rack. That server is now deployed on the network rack. We can see that it is powered on and that we have a network interface ready for connection. I will go ahead and click on Connections, and I will click on a straight through cable. When I click on the straight through cable, I will click on the network interface card for Fast Ethernet 0 of the server, and then I will click on any port I would like to connect it to. If I want a closer view of what port I'm connecting it to, I can always right click on the switch and click Inspect Front and zoom in for a closer view. With the zoomed in front of the switch, I can easily identify what port of the switch I would like to connect to. For example, I would like to connect to port 24, which is FA0/24 on this 2960 switch. When I click on that port, the cable is now connected. If you feel that the cable is getting lost, you can always right click on that cable and change the color as we mentioned earlier. I can make it red, for example, and click OK. And now it's much easier to find the connection from the server to that Cisco switch. This is the power of Cisco Packet Tracer utilizing the logical and the physical views. Please practice and enjoy using Cisco Packet Tracer for all of your network configurations and for any scenarios that you could possibly imagine and build.
All right, and I found that video within Netacad, but it is also available out on individually out on YouTube. Now I want to leave my screen. I want to share with all of you, and that's the power of having real equipment. Now, if you know you're going to be a Cisco technician and you are going to work with routers and switches for a living, you make some good money in it, just starting out at 40 grand and going up into the hundreds pretty easy. The one of the things you can do is buy a pre-owned stack of routers and switches. Now, I just did a quick search on eBay. I'm not recommending any individual one, but I did a quick search for CCNA router switch lab kit. And this is basically what you are looking for. You are looking for something that has, let's see if I can zoom in. Yeah, that has uh, two or three switches and hopefully three routers. You need three routers. In this stack, they have five, it looks like five routers and three switches. So this would be an excellent stack to use. These are switches. You can always tell because there's lots of ports on them. But anyways, that's just one example. 450 bucks. I'm not going to check the actual age. The routers and switches do not have to be. Here's an example of poor cable management, right? the three routers and the two switches. So they don't have to be cutting edge routers and switches. That could be thousands of dollars. They can be older routers and switches, as long as preferably running iOS 15 or newer, but even iOS 12 or newer is fine. You don't really want an operating system older than iOS 12 because it will be significantly different. But anything iOS 15 or I'm sorry, 12 or newer, you're fine. If you get an older piece of equipment, you may be able to load newer software on it, but make sure you secure the software if you're going to try to upgrade, and make sure that software is compatible with the equipment you're buying. But anyways, again, all I did was a quick search on eBay for CCNA router switch lab kit, and you're looking for three of each is the best of everything, but you need three routers and two switches, and then multiple hosts. Ultimately, set up your laptop and your PC, and maybe an older computer, and you have everything you need to do all the labs, all the way through CCNA, all the way through Cisco 1, 2, and 3 here at the college, or if you're doing it at a different school. All right, so that's that. That would be if you wanted to work with real equipment instead of Packet Tracer. Again, you can get Packet Tracer on Cisco by signing up for going to see by going to Netacad, NETACAD. It stands for Net Academy, netacad.com. And on Netacad, you can sign up for the free ones out there. There are lots of free ones that you can sign. You register for a Cisco account, sign up for a free Packet Tracer account. They give you Packet Tracer to do the assignments, and then you have Packet Tracer. There's several different labs that different ways to get that software for free from Netacad directly. That's where you're supposed to get the Packet Tracer software, and you can get the newest software. All right, you can find it out on the internet elsewhere as well if it isn't. Now looking for the newest version, you can do that. All right, our presentation's an hour and a half long. That's plenty. I wasn't expecting it to be this long. My name is Don LaFont, Professor Don, and this week we began our coverage of networking, Chapter 13, in our A+ software class. If you have any questions and you're here with me now, I'll be available for questions in just a minute. You can also ask questions inside of our NetAcad classroom if you're taking me in the summer of 2022. And you can also ask questions down below in the comment section of my YouTube channel, and I'll be happy to try to answer it. But please help each other out. I love to see that community where students of networking help students of networking. It's fantastic. And it lets you practice your soft skills. Anyways, thank you for coming to class. I really appreciate it. And if you're out on YouTube, give me a thumbs up and follow me so you know when the next video is out. Hit that notification bell. I'll see you again in a week. And thank you for coming to class.